Okay guys, well you just got done learning how to factor using the greatest common factor, and so now we're going to go ahead and apply this to certain polynomials in order to be able to fully factor them. So in Algebra 1 you guys learn how to factor polynomials that are quadratic, that means power of 2, and so typically when the power is larger than 2, we'll normally have to factor out our greatest common factor, and then we'll move forward with the process that you guys learned last year. So if you take a look at this equation right here, we're looking at y equals 4x to the power of 3 plus 14x squared plus 6x. If you notice at this first term right here, that power is 3, and so that makes it not quadratic, that makes it cubic. So in order to factor using that x method, we have to factor out something that's common. So if you take a look at each of these pieces, I've got the number 4, number 14, and the number 6. All of those numbers are divisible by 2. And that's the largest number that divides into 4, 14, and 6 is 2. And so that's why 2 is part of the greatest common factor. But if you also take a look here, this term has an x cubed. That means it has 3 x's. This term here has an x squared. That means it has 2 x's. And this term right here has just a plain x, so it has 1. So they all at least have 1x. And so that's why this 1x right here is part of the greatest common factor. So our greatest common factor here is 2x. Each of these numbers is divisible by 2. That's the biggest number that divides evenly into them. And they all have at least 1x in common. So what we do now is we take that greatest common factor and we divide each piece of it by the greatest common factor. So I've got my first term, 4x cubed. We divide it by the greatest common factor, 2x. We do the same thing with the second term. We do the same thing with the third term. Then if you remember from last week, we write that greatest common factor on the outside, and then the inside piece here is the result from our division right here. So the 2x is our greatest common factor that goes first. Right here, 4 divided by 2 is 2. And then if I take that 1x away from 3 of them, I've got 2 of them left, and that's why we have 2x squared. You can also think of this, if you remember your exponent properties, that's a power of 1, that's a power of 3. We divide the bigs, subtract the smalls. So dividing the bigs, 4 divided by 2 gave me 2. If I subtract my smalls, 3 minus 1 gave me 2. Another way to look at it. If you look at this second piece here, we can go with that process of dividing the bigs and subtracting the smalls. If I divide the bigs, 14 divided by 2 gives me 7. If I subtract the smalls, that 2 minus that 1 gives me 1 right there. Lastly, same thing. If I take 6 divided by 2, that gives me 3. And then right here, hopefully you'll recognize and remember that those x's cancel out. So this portion right here is the factored form of the original using factoring by greatest common factor. That's what we did last week. Now this week we're going to take it one step further, because now if you look at this inside piece right here, that's quadratic. That's the biggest power of 2, then power of 1, and then power of none. And if you look back in the previous slides, you'll see that this is in the form ax squared plus bx plus c, and that's standard form quadratic. So if you can see for that standard form for a quadratic, the a value is 2, that's where we get that. Second value is b, which is 7, that's where that comes from. And then the last one is the c, which is 3, and that's where we have that. We're going to forget about this GCF out here for a second, and we're just going to factor the inside now using that x method that was in those previous slides. So here's a template set up. If you remember, the b value goes on top. B is 7. We got that from here, and we also got that from that quadratic portion on the inside. So again, my b value is 7. Now down here, we take the a value, which is 2. We multiply it by the c value, which is 3, to get 6. Okay, so if you remember, we're looking for factors of 6, numbers that multiply to give me 6, but add to give me 7. So factors of 6 are 1 and 6. 1 times 6 is 6. Factors of 6 are 2 and 3. 2 times 3 gives me 6. Now we just need to pick the ones that add up to give me 7. Well, 2 plus 3 is 5, not 7. 1 plus 6 is 7. And so that's why we use those two values. 1 times 6 gives me 6, the bottom portion. 1 plus 6 gives me 7, the top. So I take those factors of 1 and 6, I put them on top. 1 over here, 6 over here. If you remember over here, the a value with your variable goes on bottom, and that's why we have 2x on the bottom on both sides, because a is 2, variable is x. When we have an a value bigger than 1, we're always going to need to see if those fractions reduce. So 1 over 2, that's not reducible. 1 is the biggest value that goes into both of those numbers. Over here, 6 divided by 2, both of these numbers are divisible by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. Okay, and if you remember, the way that we write our answers is each fraction here is going to be its own set of parentheses. And we're using this fraction here because it's the reduced one. But now we've got to bring back that original greatest common factor that we used, because we factored twice. We factored the GCF out, and then we factored this quadratic piece, and we're going to use these parts here to write the answer. So the 2x over here is the greatest common factor. This 2x plus 1 came from this left fraction. We take the 2x on bottom, that goes first. The top number goes second, it's a positive 1, and that's why we wrote plus 1. Over here, we get the x plus 3. Well, if you look over here, that's 1x. There's really a 1 in front of that x, but we hide it. And where did the plus 3 come from? Because that's a positive 3 on top. So you take your greatest common factor that you factored out originally, you take the quadratic piece that we factored using the x method, and the combination of those together is the factored version of our original problem. I really hope this helps, and please watch this video as many times as you can. Pause it, rewind it, let it be a good resource for you. Good luck.